morning. This is lesson MCS Geometry, lesson 78, page 511 in your textbook. Please get out your graph paper and a straight edge for your warm-up. This lesson will be on rotations. Very interesting. And your warm-up, number 1, is a change in position, size, or shape of a figure or graph is called a transformation. It included size and shape. Number 2, translate the triangle with vertices located at D, 1, 3, E, 3, 6, and F, 5, 1, and move it along, translate it along the vector, -3, -4. This is found right here. The orange triangle is DEF, and some X and Y components of the vector are sketched in. And the black triangle is your D prime, E prime, F prime, has moved over -3 in the X direction, -3X, and -4 in the Y direction. I hope yours looks like that. Number 3 is to reflect triangle ABC across the y-axis. Right here in the red, the A coordinate is 1, 2, B is 3, -2, and C is 2, 5. Across the y-axis, we're going to change the sign of the X component. So A prime is -1, 2, B prime is -3, -2, and C prime is -2, 5. Over here, the ABC, triangle ABC, is in red, and its reflection is in black with A prime, B prime, and C prime. Very nice. I hope you did well. This is an interesting lesson about rotating about the origin, or rotating about a point. First of all, a definition. A rotation is an isometry, meaning that the pre-image and its rotated image are the same shape and size. So this question asks us to rotate about the origin. They start with triangle MNP, and I showed M as coordinates x, y, so that you could later see the M prime. The translated M is we are going to do -x and -y for our M. Indeed, 180 degrees brings it to the third quadrant, where all points have a negative. First, we're going to rotate about the origin, and 2, the angles of rotation are multiples of 90 degrees. These are special, because 90 degrees, we know at 90 degrees, our translation of xy will go to -yx. So we flip them. 180 degrees is xy goes to -x, -y. What we're going to do in this problem. And rotating 270 degrees, xy goes to y, -x. Triangle MNP has these vertices of M11, N43, and P52 plotted up here. And it's rotated 180 degrees about the origin. Therefore, we are going to apply this rule right here and take our 1, 1 and make -1, -1. Take our 4, 3 and make -4, -3. Take our 5, 2 and make -5, -2. And over here in the pink, we have the reflected, rotated image 180 degrees. Very fun. Now we're going to rotate about a chosen point. We're going to start with a point, P, which is located here in orange. And we're going to rotate it around point R. P is right here, excuse me. R is up here. Now we're going to look at the y distance between them, between P and R. One's at y of 4, there's y of 6, there's 2 between it. So if we're going to rotate it, it rotates as that's its radius, so it will always be 2 away by distance. And so if we're going 90 degrees, we know we will change the coordinates. So P prime is going to be 2 away from R also, but it's also going to be to the right. So if we have our original point, x, y, in general terms, our P prime is going to be x plus 2, y plus 2. Let's put in those numbers. First we started with negative 3, 4. So now we're going to have negative 3 plus 2 and 4 plus 2, which gives us our P prime of negative 1, 6. And indeed, when we bring it up here, this is our new point P prime. On example B, P prime, they're going to pick a different P prime. Sorry, it's over here. It's 7, 8 is its coordinate. We're going to rotate it about this second rotational point, R prime, and I nickname it AB and nickname this one XY so that you can see the transformation that the book gives us. The transformation of XY rotated about a point is 2 times the x-coordinate of the rotational point minus the x of the point, and 2 times the y of the rotational point minus the y of the initial point. So 2 times negative 2 minus 7 is the new x-coordinate, and 2 times 3 minus 8 is the result for the y-coordinate. That equals minus 11 minus 2, or negative 11, negative 2. In our lesson today, those are rotations of around a certain point. And we're looking at this transformation right here. Go ahead and put on your smart sheet. And any of these rules up here, this, if we want to write down the instructions on how to rotate around a point, chosen point, put them on your smart sheet. This right here for 90 degrees, 180, and 270 degrees should also go on your smart sheet. Have fun with your lesson. We'll see you tomorrow.